All right, let's get started. Today, we're going to be mathematical detectives. We're going to start with something we all think we know, the good old factorial, and uncover the secret family of functions that takes it to a whole new level. It's pretty cool. So let's jump right in.
So you know how factorials work, right? 3 factorial is just 3 times 2 times 1. Super simple. But what about this? What in the world is 1/2 factorial? All of a sudden, that simple idea of counting down to 1 completely falls apart. I mean, how would you even start to figure that out?
And this leads us to our first big mystery, what I'm calling the impossible factorial. Because at first glance, it really does seem like a question that has no answer.
And yeah, if you stick to the textbook definition, you've hit a wall. The factorial we learn in school is a members-only club for positive whole numbers. No fractions allowed. And this is where most of us would just stop. But you know, in math, a dead end is really just an invitation to find a new road.
And that new road? Well, it has a name. So let's meet the hero of our story, the gamma function. This is the key that's going to unlock this whole thing for us.
Okay, I know what you're thinking. Whoa, that looks intense. And yeah, it's a pretty beefy-looking integral that goes all the way from 0 to infinity. But look, don't get hung up on the formula. We're not here to solve it by hand. What really matters is what this incredible tool actually does.
So let's just boil it down. The gamma function is basically a massive upgrade. It takes the idea of the factorial and stretches it so it works for pretty much everything. Think of it like the factorial's superpowered cousin who can handle not just whole numbers, but decimals, fractions, even complex numbers. And here it is. This is its defining superpower. For any positive whole number n, the gamma of n is exactly the same as n minus 1 factorial. This is the proof. It shows this isn't some random function. It perfectly extends the one we already know. So gamma of 4 is 3 factorial, gamma of 5 is 4 factorial, you get the idea.
So this is how we crack the case. We just use that superpower. To find 1/2 factorial, we need to find the gamma value that would give it to us. So we're looking for gamma of n, where n minus 1 is 1/2. That means n has to be 3/2. All we have to do is calculate gamma of 3/2.
And boom, there it is. The answer to our impossible question. 1/2 factorial is the square root of pi divided by 2. How wild is that? This amazing function somehow connects whole numbers, fractions, and these crazy transcendental numbers like pi all together. It's just beautiful.
But hold on, the story doesn't stop there. Just when you think the mystery is solved, a new character walks on stage. So let's meet the gamma function's mysterious relative, the beta function.
And here's its formula, another integral from the mind of the great mathematician Euler. Again, don't worry about the nuts and bolts. Just notice a couple of key things here. First, it takes 2 inputs, an x and a y. And second, check out the limits on the integral. It only goes from 0 to 1.
Let's put these two side by side, because this is where it gets really interesting. The gamma function goes on forever, to infinity, and its main job is to be a bigger, better factorial. But the beta function is contained. It lives only between 0 and 1, and its whole deal seems to be about the relationship between 2 different things, x and y. They really do seem like they come from different worlds.
And that brings us to the big reveal. Because despite looking so different, these two functions share a deep, dark secret. It's time to uncover the family connection.
I mean, you've got to be asking yourself, right? With their different formulas, their different inputs, their different jobs, how on earth could they possibly be related? It seems like a total long shot, maybe just a coincidence.
And then you see this. This is the moment where everything just clicks into place. This ridiculously elegant formula shows that the beta function isn't some distant cousin at all. You can write it entirely using the gamma function. It's just gamma of x times gamma of y, all divided by gamma of x plus y. Mind-blowing.
So what does this all mean? It means these aren't just 2 clever functions that mathematicians dreamed up independently. They are deeply, fundamentally connected. They're 2 different branches of the exact same mathematical family tree, and each one tells us something unique about a much deeper structure.
Okay, so we've solved the puzzle, we've uncovered a secret family, but why does any of this matter? What's the point of all this, outside of a math class?
Well, it turns out this family is an absolute powerhouse in the real world.
In statistics and probability, they form the backbone of these crucial distributions that we use to model all sorts of things. They pop up everywhere, from complex analysis to physics and engineering. They aren't just abstract ideas, they are workhorse tools that help us make sense of the universe.
And that kind of brings us to the final thought here. We started with something as simple as a factorial, and it led us down this rabbit hole to a whole hidden family of functions that are used all across science. It really makes you wonder, doesn't it? What other beautiful connections, what other secret families are just hiding there right in front of us, inside the math we think we already know?